Welcome back, students. Today we're going to be talking about solving equations with the variable on both sides of the equation. In order to solve an equation with the variable on both sides, first thing we're going to want to do is to simplify one or both sides of the equation. What I mean by that is you're going to combine like terms. You're going to distribute if you see distributive property. We're going to do those steps first so that we can access the variables nice and easily to get it on one side. Then we use inverse operations to collect the variable terms onto one side. We collect the constant terms on the other side. And then we're going to isolate the variable. Now, the inverse operation that we're going to be using to get the variable onto one side is going to be addition or subtraction. So try to remember that. That's important for today, is to remember that we are going to use addition or subtraction to get that variable onto one side. So here's our first equation. 10 minus 4x equals negative 9x. We got the variable on both sides. I don't really see anything to simplify, and even though we've got two x terms, I can't use combining like terms because they're not on the same side. Only time you can combine like terms is if they're on the same side. So I either want to eliminate negative 4x or negative 9x. It doesn't matter which one you actually pick. You can eliminate either, and this is going to work out just fine. I have a preference, though, for picking the lower one. So in this case, the negative 9. Negative 9 is lower than negative 4. The reason I like to pick those is you'll notice as I add a negative 9x to both sides of this, I get positive 5x. Now, had we chosen to add 4x to both sides, we would have eliminated this. Negative 4x plus a 4x would have given us a 0 over here. And then we would have gotten negative 5x over here on the right side. So by choosing to eliminate the negative 9 rather than the negative 4, I get a positive 5x rather than a negative 5x. It's not a big deal. If you get a negative 5x, meh. You can still solve it. It's not a problem. But if negatives sometimes prove to be a problem for you, this is a way of avoiding having that negative coefficient. Now that I've got 5x alone, not alone, but I've got 5x over here, I now need to eliminate things like the 10. So minus 10 from both sides, and we get 5x equals negative 10. Now I need to eliminate that 5 because it's a multiplicative relationship. We will use division to eliminate it. So 5x divided by 5 is just going to be x. Negative 10 divided by 5 is negative 2. Now, final step, very important. Check your answers. In order to check our answers, we just rewrite the equation. We change the x in the equation to our answer, in this case, negative 2. We're going to get 10 plus 8 is equal to 18. 10 plus 8 is 18. This is a true statement. This is definitely the answer. All right, so this time we've got these grouping symbols. Now, this is what I was talking about using distributive property. We are going to distribute these out so that I can then do the addition or subtraction inverse to eliminate the x from one side. Pay close attention to also on the right side, we've got a fraction that we're going to multiply through. So pay attention to how that works. It's just multiplication of fractions. So if you're comfortable with that, then this isn't going to be an issue. If you do struggle with that, pay close attention to that step. Now, first I multiplied through the 3. 3 times 3x, 3 times negative 4. Same thing over here. 1/4 times 32 over x. The 1 multiplies to the 32. 1 times 32 is just 32. And the denominator of 4 stays the denominator of 4. And we just stick it on the bottom. Same thing with this next one. 1 times the 56 is a 56 with a denominator of 4. So simplifying that further, we get 9x minus 12 equals 8x plus 14, because we did 32 divided by 4 is 8, 56 divided by 4 is 14, 3 times negative 4 is negative 12, 3 times 3 was 9. Now, once again, I am choosing to eliminate the lower one. I had a 9x and I had an 8x. I'm choosing to subtract the 8x from both sides to avoid those negative numbers. So 9x minus 8x is just x. 8x minus 8x is a 0, so we just bring down the 14. Now I just need to eliminate the minus 12. Opposite of that, add 12 to both sides, and we get x equals 26. Okay, now the checking step again. Write the equation. Change x to the 26, and we're going to simplify. We're going to start inside the parentheses first, following PEMDAS. So we get 3 times 26 is 78. 32 times the 26 is 832. Now 78 minus 4 is 74. 832 plus 56 is 888. 3 times 74, 222. 888 divided by 4, or 1/4 of 888, is 222. So both sides came out the same. This is a true statement. We found the correct answer. So this is what it's going to look like when you need to distribute before eliminating the variable from both sides. Now, equations do not always have one solution. Everything we've worked with so far, if we were to look at it graphically, looks like this. You've got two lines, and then there's just that single point, that one number at which they are the exact same value. However, we can have equations that are true for all values of the variable. Now that is if both my equations, even if they don't look it initially, they are exactly the same. Kind of like 1/2 is a 0.5. The numbers may not look the same, but they are. Same thing can happen with equations. You can have equations that might not look the same, but as we begin solving them and simplifying them, and we look for the solutions, we find this situation that, oh, both sides were the same. It's always going to be true. Okay. This is called the identity, and it's going to have infinitely many solutions because the solution is where they cross. If it's the exact same line, they cross everywhere. All right. Finally, if we've got two lines that are parallel, okay. In this situation, they never cross. There is no solution. There's no value of x that makes that equation true. Okay, so let's take a look at some of these. All right, so we've got this equation. I see distributive properties, so I'm going to start with that. So now 3 times the 5x and 3 times the 2. Simplify that further. 15x plus 6. I've got x's on both sides. Now I'm ready to eliminate those. So minus 15x from both sides. Now notice both of them were 15x's, so both just got eliminated. 15x minus 15x was 0, and we got those zeros on both sides. And now we've got 6 equals 0. This statement is clearly false. 6 does not equal 0. Now, what this is telling me right now, I was trying to find the value of x that could make both sides true. My x's disappeared, and I just got a false statement. What this is telling me is this equation can never be true. There is no value of x that makes it true because there's no value of x that could ever make 6 equal a 0. It's impossible. So there is no solution. So whenever you solve an equation and you get this statement that is just false, it cannot be true, that means there is no solution. All right, let's look at another example. Once again, we're going to start with simplifying by using distributive property, multiplying that -2 to both terms on the inside. Simplify that. And now I want to eliminate the variable from one of the sides. So we've got negative 8y. I will add 8y to both sides of this equation. And I eliminate both of the variable terms, and now I'm just left with negative 2 equals negative 2. Now, similar logic to the last one, but this time it's true. So what's the value of y that makes negative 2 equals negative 2? Well, any value. In this situation, this equation will always be true, because even as we see from this step up here, even though they looked different at the beginning, this was the same equation on both sides. It was the same expression. Therefore, they're always going to be the same. No matter what number we use for y, these are going to be equal. So when you're solving, and this time rather than getting some false statement, you get a statement that's always true, that means it doesn't matter what y is, negative 2 always equals negative 2. This is always going to be true. Because of that, there's infinitely many solutions. Okay, so here's a little story problem for us. A boat leaves New Orleans and travels upstream on the Mississippi River for 4 hours. The return trip takes only 2.8 hours because the boat is traveling 3 miles per hour faster downstream due to the current. How far does the boat travel upstream? Okay, so first, looking at the words and noticing some of the things that were in there. We had hours. We had how fast it was going. That's a rate. And the final question, how far? It's asking about distance. So we're going to be using the distance equals rate times time equation because those are all the variables they're giving us, and we know how these are related. The other part of this is that both the downstream and the upstream trip were the same distance. I don't really know what that distance was, but we know it was the same. So what we're going to do is create an equation where we've got the rate times time of the first trip, of the downstream trip, is going to be equal to the rate times time of the upstream. And that's because they both went the same distance, so they can be equal. So in the first one, we don't know his rate, but we know he went for 4 hours. As they were going downstream, we know they went 3 miles per hour faster. So we have the same rate plus 3 miles per hour faster multiplied by the 2.8 hours it took in that trip. All right, so now we've got our equation. We can begin solving it. All right, so I've got the r on both sides of this equation. I'm going to pick the lower one, the 2.8, and eliminate that. So now I've got 1.2r equals 8.4. I'm multiplying by 1.2, so the opposite, the inverse, would be to divide by 1.2. R equals 7. Now, this is a word problem. You need to give a word answer. So, but even before we can do that, we need to focus in on what was it even asking. Now, I just found out that the rate they were traveling was 7 miles per hour. Great. Look at what the question says. I even just barely made this mistake. How far does the boat travel upstream? If someone asks you, how far did it travel, and you say 7 miles per hour, you're being kind of weird. So now we're going to use this rate. We know how fast the rate was, 7 miles per hour. Now we got to figure out the distance. So 7 miles per hour for 4 hours takes us 28 miles. The boat traveled 28 miles. And now we've got our final answer. I hope that was instructive. I hope that helps you. If you've got any questions, please send them to your teacher.